Now let's see how we can price an interest rate swap. We will take the same approach as for forward rate agreements, namely we will start from the end and then come back to the beginning, and that is, we will see how we can value a swap that already exists, and then use that result to determine the initial rate that we should set on a swap when we create the swap for the first time, right? Okay, so let's start from the value of an existing swap, right? The same idea again, namely at the initial moment the swap has a price of 0, neither side has to make any payment, so the price is 0. But as time moves forward, interest rates change, or interest rates may change in the market, and therefore the swap may have a value that may differ from 0. It may be positive or it may be negative, okay? And that's that new value that we want to determine. All right, so the formula is this one here. This is the value of the swap. This comes from the use of our two hammers, which is a fixed rate bond and a floating rate bond, right? So the details of how this formula comes about are discussed here, but let me try to explain this with an example, right? So let's continue with the previous example, which was this swap we used in the previous video, a swap of 4% fixed for the 6-month LIBOR, right? Okay, suppose that some years have passed since the creation of the swap, and we are very close to the end now. Termination is in 8 months, okay? The swap curve is currently flat at 3%. So what I'm using here the term the swap curve, but what this really the reason for this number here is that this is the number we should use as the discount rate. So we are going to discount cash flows at 3%. Okay, we will discuss later on why we should use these rates, but for now just take this as given. The discount rate is 3%. And we also know the value of the floating rate, the 6-month LIBOR in this case, at the last reset date, because this was in the past. Okay, so let's say it was 3.2%. All right, so we want to compute the value of the swap at this moment, and we have to pick a side because the signs will either be positive or negative, depending on whether we are on the side of the firm or the bank. So let's say we want to compute the value for the firm, right? The firm was the fixed payer in the swap. Okay, so that's the side we want to take. All right, so let's open this here. Sorry, to make sure you see my window here. Okay. So there's a lot of stuff here. For now, ignore the green color. Let's look at the timeline first. So we are taking the side of the firm, which is the fixed payer again. This is my current date today. There are just 8 months left. This will be the final payment in the swap. Since the payments are 6 months apart, we have this last one, and we still have one in 2 months from now, right? The fixed payments are known. That's well defined. 4% divided by 2 in each of these moments. The firm is the fixed payer, so this comes with a minus sign here just to stress that these are payments. The other leg is the floating leg, so we'll have a payment here that depends on the 6-month LIBOR. On which LIBOR? This works exactly like a floating rate bond, so it depends on the LIBOR that was defined at the last reset date. So I go back in time, look at the market 4 months ago, see the LIBOR on the market at that moment. Let's say it was 3.2. This will define the next payment. So this one is known. Okay. But then we also have the last one, which is this one here, which is the floating rate, which will be defined only 2 months from today. So this one is random, right? So it's the usual problem that we have seen many times. So we now know exactly how to handle this. So this has to look like a floating rate bond so that I can apply the pricing arguments for floating rate bonds. There's just one detail here, which is exactly the same issue that we have in the forward rate agreement, which is the swap, now in this case, does not call for exchange of principal. But if I put the principal on the floating leg and the principal also on the fixed leg, the two cancel out, and it's fine. I'm back to what the swap really is, which is no exchange of principal. Okay. This does the trick, because if now I put the face value here, this is exactly like a floating rate bond, and then I know that the price at the next reset date will be exactly 100%. Right? So now I'm done, basically. These are all fixed cash flows. This is fixed, this is fixed, this is fixed. Everything is known. I just do the usual discounting with the current term structure of interest rates. So that's what we are going to do. The value of the fixed leg, this part here, it's just the present value of these two cash flows, this one and this one, using the current spot rates, which we assume it's 3% for all maturities. So 3% for here and 3% for 8 months as well. Okay, so that's the value of the fixed leg. The value of the floating leg is just the present value of these cash flows here. So 1 plus the 3.2%. Everything again discounted at 3%, and that will give me some number, right? I want the value of the swap for the firm, which is the fixed payer. Okay, so let's do that. The value of the swap for the fixed payer, meaning if I am paying fixed, I am receiving floating, so plus here on the float, and I'm paying fixed again, so a minus on the fixed leg. The notional, in the previous example, this was defined as 10 million, so I scale this difference by that amount, and the value comes out to be this amount of dollars that you see here, right? The sign is important. So a minus sign here, since I am computing the value for the fixed payer, means that this is a liability for the fixed payer, meaning a liability for the firm. So what does that mean exactly? Here, the swap has not ended yet. We still have 2 more payments to go. But if for some reason the firm wants to terminate the swap right now, at this moment, then the fair amount to pay to the other counterparty, to the bank, is this. All right? So the firm needs to pay this amount if the firm wishes to terminate the swap right now. Okay. All right, so now let's, step 2, move back to the beginning of the swap and determine the fixed rate that we should set when the swap is created, okay? So again, by definition, an interest rate swap calls for a 0 payment in the beginning. Neither side pays the other side. Neither the firm pays the bank nor the bank pays the firm. So if that is defined to be like that, if the price is 0, that has to mean that the 2 legs, the fixed leg and the floating leg, have to have the same value. Right? What is the value of the floating leg? Well, we are at the beginning of a reset date, so the value of a floating rate bond at the reset date is 100%. 100%. I just said that the 2 legs have to have the same value, such that the whole package has a value of 0. So if the floating rate bond, which corresponds to the floating leg, has a value of 100%, the other leg has also needs to have the same value of 100%. So basically, we are going to define the coupon rate such that the value of the fixed leg, including the principal, is 100%. Okay? So very quickly, simple example. Suppose that a large bank, a market maker, can borrow or lend at the following rates, 6 and 12 months, okay, 1%, 2%. And what would be the rate that this bank would quote on a very small swap, just a 1-year swap, that pays fixed every 6 months? Okay. Sorry, this one. So again, the idea is the following. We are going to determine the coupon rate, which will be a C with a compounding frequency of 2, because the swap calls for semi-annual payments, such that the value of this fixed rate bond, okay, is equal to par, to 100%. So it is just a simple pricing equation. present value of these two cash flows, first coupon, second coupon, and principal, has to equal the value of the floating leg, which looks exactly like a floating rate bond when I include principal on that floating leg as well, like I am doing here in the fixed leg as well, so such that the two principals cancel out. Okay, so this is an equation in one unknown. I can solve for the coupon rate C2, and that's the number that comes out. So this is the quote that the bank should show on an interest rate swap for 1 year with semi-annual payments.